Nice to see you today. My name is Hong, and I'm quite excited to kind of be here at Avox to kind of discuss different technologies and maybe do a bit of deep dive and different things that we're good at. So I think, so today, the talk I'm giving is on two main things. So one is streaming data pipelines, and the second one is Flink, and how Flink fits into like helping you manage your streaming data pipelines, right? So I think just want to do a quick survey before I start the talk, right? How many of you guys have heard of Apache Flink? Like, this big squirrel. Oh, quite a lot. That's good. Great. Okay, I guess how many of you guys kind of work with data pipelines or data lake, data streaming on a day-to-day basis? Oh, great. Okay, let's go. About half. Yeah, nice. So you guys are in the right place. So here, I think the main, like, it's a tools in action video, so talk. So we're just going to talk about like the main challenges around handling streaming data and how Flink helps you manage this seamlessly, right? So that's the goal. And hopefully at the end of the talk, you kind of get a better understanding of what Flink is, right? How it handles these things, and if you have any issues, you can debug it yourself, right? And I'll end it with a short demo as well. Cool. So a bit on myself. I'm Hong. I'm a software engineer at AWS. I work on the managed service for Apache Flink team. I've been there for 3 years. I'm also a Flink committer, so I help maintain the repository. I've been active for about 3 years now. So on our service is kind of, we run a Flink cluster for you, and we manage the job for you as you run your Flink job. So I mean, in the last 3 years, I've been in the job of like kind of operating and making sure, like the streaming job is up and running and optimized for your purposes, right? So hopefully you can share a bit of knowledge, and feel free to come and catch up later after the talk if you want to. Cool. So this talk I mentioned earlier is going to be about data pipelines and Flink. So first, let's kind of explore the concept of streaming data pipelines, right? To understand that, you guys kind of know, but actually just for people who are a bit more new, right? What is streaming data, right? Let's look at that, right? So the first thing is this kind of a quick overview of what streaming means, right? Streaming as compared to batch, right? So if you imagine data, like imagine a data with timestamps or event-based data. So each block here would represent maybe some form of event that's happening. Let's say you make a purchase, or you open up your phone, or you click. So it's some form of event that has happened. And also it's a timestamp, right? So you have a stream of data that's flowing through. Let's say you scroll your phone, you have a stream of data of what you're looking at, right? So one way of, let's say, you process that data is batch-wise. So what you do is, let's say you want to kind of analyze this data every 30 minutes. So what you do is you chop it up into 30 minutes chunks, like you can see below here. You chop it out into 30 minutes chunks, and then you process it every 30 minutes. That's kind of batch processing, right? And the idea is that gives you some form of analytics where you have the whole scope of the data that you're looking at. Whereas streaming data is kind of an easy way of saying it is you process it continuously. The moment each record appears, you process it, right? So that's stream. So you can see there's little arrows coming up after every single event. So instead of waiting for 30 minutes, you process it the moment the data arrives. So what's the benefit of this, right? The first thing is you get real-time data. The moment something happens, you get the analytics, and you can adjust kind of based on your system. So you can kind of use this for, I guess, event-driven systems. The moment something happens, you trigger something else. Or if you want to do some analytics, let's say you want to have a dashboard that's updated in real time, right? That's something that you want, right? Real-time analysis, so that you can drive other business decisions that you have. So just a quick overview of what batch versus streaming is. Let's kind of look at like a real-time data pipeline. Just going to give a quick example of maybe a possible use case. It's going to be quite simple, but I mean, you can kind of build more complex architectures later on. So imagine, let's say you're a company, right? Let's say, and you have lots of, you're tracking purchases or how users use your website across the world, right? They can use it on the phone, they can use it on a laptop. And let's say you want to kind of detect by location how many people are online or how many people are purchasing, right? So you have events. Let's say someone purchased something in the UK. You have an event happening in the UK at a certain timestamp, right? Let's say you want a dashboard of the world and say, hey, I want to see how many, like update live, right? In the last 5 minutes, how many purchases happened in UK and how many purchases happened in Malaysia, right? You can kind of, I mean, you can, of course, kind of tailor it to a use case. I'm just giving an example that I can kind of show and visualize, right? So in this case, let's say your dashboard, like in the last 5 minutes, there's 5 in the UK, 3 in Malaysia, right? And you want your dashboard to kind of update, every 5 minutes, maybe 3 and 4, right? And then it kind of goes back up. So you kind of want a dashboard to update automatically, right? And in real time. So it's important to kind of get live data for this. So how will you build the backend for this? That's the question we're going to talk about, right? And how does Flink help you build this backend? That's the question we're going to talk about. So cool. So imagine, let's say I talked about you have a bunch of devices. You can see that on the left, right? And let's say they're generating data, right? You put it through some form of architecture, black box, and you want your dashboard. What is in this box, right? I think one thing to talk about here and mention is that Flink kind of fits in to your existing architecture framework. So it's not something that proposes a way you visualize. You can use your existing tooling. You can use, if you're familiar with Grafana, if you're familiar with Kibana, you can use the same thing to visualize it. Flink is the engine that helps you to read the data and process it in real time. So it's something that helps you to kind of generate the analytics that you want. For example, in this example, we want to see in the last 5 minutes how many events have happened in the UK and how many events have happened in Malaysia. Flink is the thing that takes in the raw data that you have, lots and lots of data. It does the analytics for you. It says, in the last 5 minutes, I tell you this is how much you have in the UK, how much you have in Malaysia, and then you can use your own tooling to visualize it, right? That's why I don't really focus on the kind of like making it look nice, because you can use whatever you want. It doesn't matter. That's not Flink's job. Flink's job is figuring out the analytics for you and getting it right, meaning I'm going to show you in some cases, in real-time data, your data kind of follows different patterns, right? So maybe sometimes there's a heavy load, sometimes there's a low load, sometimes there's network disconnection. How does Flink make sure in all of these cases you have the same answer? That's what you want. You want the correct answer, and Flink focuses on that. So how you visualize it is up to you, right? And how you generate the data, you can use different tooling. I think if you guys are familiar with streaming, you can look at like Kafka, you can look at Kinesis data streams. It's up to you. Flink is agnostic of that. The Flink, I mean, you can build a connector. But the point is Flink focuses on getting the analytics right? So now we're on the same page. Let's look at an example of how you do that. So let's say you have lots of devices, right? They generate some form of event. You store it in some form of streaming data source. I'm using Kafka, for example, because if you're familiar with streaming data, Kafka is quite a good use case usually. So what's the benefit of Kafka, right? So Kafka is some form of a like event log that you kind of, every time you have an event, you just append to the end, right? It's an immutable event log. And the reason why you would choose something like Kafka versus like S3, right? S3 is quite cheap. You want something that's a streaming data source, and the reason data store, and the reason you want that is because when you think about streaming, you want some form of like kind of store that has like sequences or like ordering in its base kind of key, like first-class citizen. Basically, you want something that ensures that ordering and timestamping is a first-class citizen. Because as you can see later, timestamping is very important for real-time data because you want something that's immediate, right? You want to check what's the last 5 minutes. You can't do that if you don't have timestamping. So you want something that's a streaming data source like Kafka. And then Flink will be the thing that helps you transform. And let's say I just use S3 as an example of, so I mentioned you have all the events, the raw events in Kafka. Flink will take it, process it, gets you your analytics, and you can store it wherever you want. I've just used S3 as an example, but you can use Elasticsearch, you can use OpenSearch, whatever helps you visualize. So I'm just using S3 as an example. So now let's look at Flink. How does Flink take you from the raw data into your analytics? So just kind of a separate view of the events, just putting some details on it so that you can talk through it later and show you how Flink actually does it. So imagine this is the stream, similar to what I talked about earlier. Each item is an event. So imagine purchases, right? Purchases happening in different countries. Let's say orange is UK and green is Malaysia, right? So you can see there are different events that's happening. Your devices will write it into a Kafka stream, whatever streaming analytics that you want. I've used numbers instead of timestamps, so it's easier to follow. But it's kind of, the idea is it's just some form of monotonically increasing kind of numbering system, right? You can use timestamps, you can use longs, it's up to you. But it's some kind of sequence numbers that helps you. So let's kind of analyze this, right? How do you generate the insight? So let's say we talked about it, like imagine if each unit is a minute, for example, right? And what we want to do to generate our dashboard is we want to go through this data continuously in real time to say, tell me every 5 minutes, how many events happen in the UK and how many events tell me in Malaysia. So this, you see on the bottom, is exactly what you want to visualize on your dashboard, right? So you want the output of UK equals 1, Malaysia equals 2, right? So you can kind of see that's what Flink needs to do. It needs to take a raw data stream that you see above, do the processing that you see, all the lines that are chopping up, and show me the final results. That's all I care about, right? And I want it to be true, depending on the situation. Like, you know, if your Flink cluster goes down, it restarts. I want it to always be true and get me the same answer, right? So that's how we're going to do it. So in Flink, you can kind of define your analytics in different operators. That's what we call it. So you can see the input stream here. You can define a source. Let's say you're reading from Kafka, your Kafka source. And then you do a key by, because you're calculating one for the UK and one for Malaysia. So you kind of key by geography, right? Because you kind of say, hey, UK events go to one side, Malaysia events go to another side, right? And then from there, I mentioned tumbling window. So you kind of chop it up into 5-minute sections, and then you perform some form of aggregation. So you say, every 5 minutes, do a count, and then write it to the output, sync, right? So that's an example of how Flink might do it. It's a very simple example, right? But the idea is that you kind of process your data, and then you output the thing. So this sounds quite simple, right? I can write a Python program to, or Java program, right? Like simple program running on a single machine as a script. Just read in input, process, and then output, right? So what's so complicated about this, right? Let's talk about some challenges, right, when you're dealing with real-time data, right? So first thing is, in real-time data, just kind of go back to the architecture earlier. One thing is, you don't know how many devices are going to be present, or whether your devices can go up, can go down. The events that you have, suddenly you have a surge of events, something have a small amount of events. That's a common challenge in real-time data. Your data fluctuates. Whereas in batch, you kind of smoothen it out, right? It's like a capacitor, because you kind of wait for an hour, so you kind of know it smoothens out average usually. But streaming, it goes immediately, and you want the data in real time, right? So your tool must be able to handle different types of data flow. So let's go back here. So what happens when you have a backlog, right? So in this case, let's say you're consuming, your stream is perfectly fine. Suddenly you have a surge in data, right? And all of this data, I guess, will have its own timestamp. Let's say your job cannot keep up. So each timestamp is still appending, right? So the time is still flowing. It's not that more events happen within a shorter period of time. The events happen, but like your job is behind. So it kind of, let's say now is 10 o'clock, right? But your job is processing the item from 9 o'clock, right? So your job is behind. And versus, let's say your job is on the tip of the stream, meaning it's 10 o'clock and you're processing 10 o'clock, right? You want the answer of what happened at 10 o'clock to be exactly the same, independent of whether or not you're processing at the tip of the stream or from a backlog. So let's look at that. Let's say you use something as simple. Let's say we do something simple, like you just wait 5 minutes. So you record the events, you go through your job, and then you just decide, I'm going to wait 5 minutes, do a sleep for 5 minutes, right? And then once it triggers, I'm going to count, right? What happens when you process a batch? So in a normal case, you have 3 and 5, right? What happens when you process a backlog, right? Within the 5 minutes, you suddenly have your job consuming a lot of events, right? Even though they all happen at different times. And suddenly you get 9 and suddenly you get 15. So that's not good, right? Because depending on how you consume the data, you get a different result. And you don't want that. You want a consistent result. You want a robust result. So what you want to do is, like, Flink uses this concept of time semantics. So it kind of helps you to ensure the data is consistent. So one thing to distinguish here is there's different types of time. So processing time is the time at which your job processes the event. That's processing time. That's kind of like, if you think about it, just wait for 5 minutes and then produce a result. That's processing time because you're waiting 5 minutes of processing time. Another one is event time. That's when the event is generated, right? So the moment the event is generated, that's an immutable timestamp that's stamped on the event, right? So that's something that you want to use because that's your source of truth. The moment you generate an event at a certain time, that's the thing that doesn't change anymore, and doesn't matter how you process it, it will give you a consistent result. And as arrival time is the time at which the job reads it. But sometimes you want to use arrival time, sometimes event time. But the point is, event time is the kind of gold standard, right? Because that's immutable. It's generated at the point of which you generate your event. So it won't change. So what Flink can do is it can use event time, right? And that's something that's built into the machine, right? The engine. You don't need to think too much about it. All you need to do is when you read a record, you extract what the event time is. Let's say, you extract for this record, read the record and tell me this field timestamp will be the event time, right? And Flink will handle all of that in the background for you and ensure that event time is the processing that you use. So what you see here is when you're processing at the tip of the stream and you say, I want to use event time, Flink will process, hey, there's 3 for 5 minutes and 5 for 5 minutes. But when you process a backlog, because the event time is static, it's immutable on the records when they were generated, even though you're processing a backlog, you get consistent results because Flink will kind of ensure that the event time is respected. So you can see that. I'll show you in the demo a little bit later. If it kind of doesn't fit in together later, I'll show you in the demo how it does it, right? And then next one, next challenge that I'm just going to quickly touch on is what happens when your events come out of order. So another thing of processing real-time data is you don't have that buffer, as I mentioned, when you're waiting a certain amount of time for things to happen. What happens, let's say, when you have devices in the UK and Malaysia, I don't know, you have latency, or you have network issues, some events get written earlier, some events get written later. So important thing to note here, I'm distinguishing between event time and the order of the event. So for example, something happens at 9 a.m., and then something happens at 10 a.m., right? And the way that you read it, usually, you will want to read the 9 a.m. one first and then the 10 a.m. one. But what happens if it's still 9 a.m. and 10 a.m., but it's written in the inverse order. So you read the 10 a.m. one first, and then after that, you read the 9 a.m. one because of some network latency that get published in a different order. So how do you handle that? And Flink has some semantics that's built in to help you handle that. So I'm going to kind of explain roughly how it does that. So first thing to mention is, I guess, a quick overview of how Flink does it, right? How Flink ensures, just go back to ensure the consistent result. How does Flink know that 5 minutes of event time has elapsed? So if you look on the records, imagine like each stack is 5 minutes worth of events, right? How does Flink know I've read up till 9 a.m. or 10 a.m., right? So what it does is that it monitors the timestamp of each record being read. And then once it reads, let's say, a record of 9 a.m., it says, okay, I've read a record up to 9 a.m. Or it says it reads a record up to 10 a.m., it'll say, I know I've read up to 10 a.m. So what Flink does is it injects pseudo records into the stream, kind of fake records that doesn't store any data, but it just tells Flink to tell I've read up to a certain point of time. So we call it watermarks, right? So it kind of it's a timestamp that keeps increasing to say my job has read up to 9 a.m., right? So what happens is that, let's say after you read 5 minutes worth of data, Flink will say, I've read 5 minutes worth of data. I'm going to generate a watermark. So say I've read up to 9 a.m. 5 more minutes, I've read up to 9:05. I'm going to generate another pseudo record called 9:05, and then say I've read up to 9:05. So any processing that needs to happen up to 9:05, you can do it, right? And then let's say it reads up to 9:10, and then it processes another watermark and say, you know, I read up to 9:10. Any processing that needs to happen happens. So what happens is that that's essential to understand how Flink handles late data. So if you look at the watermark generation, so what Flink can do is it can generate this watermark with a delay, meaning you can say, imagine like, remember 5 is the 1, 2, 3, 4, 5 is like, imagine like the minutes. So you can see in this event, it's out of order, right? You have 1, 2, 3, 4, 5, and it goes back to 1. 1, 1, 6, 7, right? How do you ensure that when you want to count the events, it counts 1, 2, 3, 4, 5, and 1, 1. So it should be 7, right? How do you ensure the result is 7? So what Flink can do is that you say, give me a buffer of 2 minutes. So I generate the watermark after a 2-minute delay. Oh, sorry, in this case it's 1 minute. But basically what happens is that it will read the records, and then it will say, oh, once I read 6, then I know that I guess I want to generate a watermark for 5, but then I've read record number 6. So I know I'm like 1 minute ahead of where I am, then I generate my watermark of 5. So you kind of generate it with a delay so that you allow a certain amount of time for the late records to come in. So this is kind of using event time to kind of allow you to process it. There's another way that Flink does it as well, which is late record handling. Let's say, you know, this mechanism doesn't catch it. You can kind of re-update your data based on late events that come in. But that's another mechanism that I think we won't touch on at the moment, but I'm just going to talk about watermark generation with the delay. So you can see here what happens is that we generate the watermark after the 6 and 7 has come in. And then because of that, we have already waited for the records 1, 1 to come in. So when we process it, we get the right result. Cool. So just to summarize, roughly what I've talked about is when you process real-time data, there are a couple of challenges. The first one is when you process a backlog. So Flink helps you to manage that by using event time instead of processing time. So your results are consistent every time. And second one is out of order and late data, right? So when you have out of order and late data, Flink uses delayed watermark generation to ensure that you can wait for the out of order data to process it. Then I guess just to show you how it's easy to use in Flink and kind of it's done like for you, you don't have to worry too much about it. Let's show you how you would implement whatever I talked about earlier, this entire job graph in Flink SQL, right? So Flink kind of is an engine and it's kind of an analytics engine. So it allows you to kind of express the analysis that you want to do in different like kind of abstraction layers. So there's a SQL API that you can use. So it's just like SQL, but for streaming data. Another one is Java as well. There's a Java API that you can use. So that's a bit more expressive. You can use, it's more low level. There's Python support as well and any JVM language support. But the idea is that I'm just going to show you SQL because it's something that's high level abstraction and easy to kind of understand. So all you need to do, I guess, to express that is just these 2 statements, right, in SQL code. And all the semantics that I talked about, the ordering and the handling of late data is done and expressed here, right? So first thing is to look at the top. One thing is you define the event. So I've kind of put the event structure here. You can see what we're doing is I'm just defining the schema of the event. So I create a table of events with geography, which is the place where it happened, and a timestamp, right? And then what I do is I tell it that I want to generate a watermark with a 1-minute delay. So that's what the next line says. I want to generate a watermark for event time as event time minus 1 minute. So that allows me to handle out of order data. So it's a delay. And then the second thing is when I want to do my actual analysis, I just define it. I say select I guess geography, right? Count for table, which is the table I had, right? Put it in a tumble window, which chop it into minutes, right? And then I want to say that I have my event time as my descriptor, right? And chop it into 5-minute intervals. So that's what you tell it. You say, I want to chop into 5-minute intervals, and I want to group by when the window start time and when the geography, like where is this? And then that will generate a results. The important thing to note here, just to think back of what I covered, is the first thing is you use event time. So what you do is a built-in first-class citizen. You can just say, I want to use event time. This is a event time notice here is a field from my record. So I say use this record as the time semantic. Don't use processing time, don't use anything. What I define in my record is the time semantic that you need to use. Second thing to notice is that you want to handle the watermark with a delay. You just write in one line, minus interval 1 minute, right? So that kind of like the Flink engine will handle it and propagate it throughout the job for you. So you don't have to worry about managing it, right? So kind of when you run it, then it kind of like handles it for you. So before I go into that, just quickly gonna do a Flink, just a demo. I'll just quickly swap over. Let's see this one. So just, oh, thank you. Let me just exit the screen. Cool. If you can see my screen. Right, so what I've done here is I'm just going to show you a quick Flink job that I've defined in Java, in the Java API. So it's similar to the example I gave you earlier, if you see here. I've defined some form of data object, just an event that has happened. It has a certain timestamp associated to it, and a location and a quantity. Let's say, I don't know, it happens like 1, right? A certain quantity, and you want to kind of aggregate it. So what happens is that when you define your Flink job, I'm just going to kind of talk it through. What you do is you just kind of set up a stream and execution environment. That's something that Flink uses that you can define your job in. And then you kind of say, read from somewhere. So create a source. In this case, I'm just reading from local file system, just to kind of for demos purposes. So it will kind of monitor continuously this file system. Whenever there's an event placed into it, it will kind of read it and process it. So it's kind of like it's not a streaming data source, but it's kind of just it's a pseudo, so easier for me to kind of inject records, right? So I've kind of pointed to input file here, and then I'll say this is a certain event class, right? In the CSV format, extract it into the event class for me. So it does that, and then what I do is I tell Flink to read from this source, right? I tell it to assign certain watermarks. So I mentioned earlier you want to extract the timestamp that you want. So you want to kind of say, hey, allow for a delay of 2 minutes. Remember the out of orderness that I talk about, bounded out of orderness of 2 minutes. And I want to assign the timestamp based on the event field. So event.get timestamp and then give me a long, right? So that kind of tells me this is my event time. And then after that, I key by the location. I do a window of 2 minutes in this case, and then tell me the sum of the quantity, and then execute the job, simple, and print it out into console, right? So it just prints out the result in the console. So then after that, you just execute. So that's how I define in the Java API. So just now I showed you the SQL API. This is the Java API, right? So you can kind of just act like this is the entire job graph that you need to run, right? So let's say now you can see in my input data source, I don't have any input. There's no records here. But if you look, I've prepared some data. Let's say I've shown you a bunch of data that's happening, that's in order, right? So you can see it kind of, it starts from 1 p.m., it goes up per minute basis, and it has a certain location associated with it, and a quantity as well, which is 1. And you can see that it kind of increases 1, 2, 3, 4, 5, blah, 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 right? And roughly some countries here and there. So what we want to do is, remember, we want to chop it into 2-minute tumbling windows and tell me, in 2 minutes, how many items happen in the UK, how many items happen in Malaysia, how many items happen in the UK, how many items in Malaysia. So you want to chop it into those kind of windows. That's what we expect, right? So let me just run the job to show you that. And then I'll put it into text. So I'll run it. Cool. So now the job is running. I've kind of removed the logs so it's easier to kind of see the output. Let's say I copy this in order data and paste it into the input. So you can see now like the job has processed. It's continuously monitoring this directory. The moment there's an item placed in it, it processes it. And you can see that it generates the output, right? Let me just show you in order, right? So we mentioned that we want to kind of chop it up into 2 minutes windows. So it says, oh, hey, in the first 2 minutes, 2 items happened in the UK. In the next 2 minutes, 2 items happened in Malaysia, you can see. And then the next 2 minutes, 1 item happened in Malaysia, and you can see that here. And then the next thing is in the UK, you can see, 2 minutes, 2 items happen in the UK, and it's shown here. So the reason you can see the timestamp is slightly different here is because I use a reduce function, right? So it kind of uses the timestamp of the first record, but you can configure that yourself. So you can see here, I just use the timestamp of the first record, and then it reduces it by summing up the quantities. So it kind of, that's why the timestamp is slightly different. And the last one you can see here in the next 2 minutes, tell me, hey, what happens, 2 items in the UK? So the next question you may ask is, what happens to all of these records, right? How come it's not printed out? It's because actually, like, remember I talked about the delayed processing? Flink is waiting for more event time records to ensure that, hey, I know that I've processed beyond a certain timestamp, so I can calculate and generate the results for certain data. So for example, so at the moment, all of these records are stored in state. It's not outputted yet. So what you can do is, let's say if I give it a record that's super in the future, let's say the end of the day today, if I put it here, then it will flush out all the data because it will say, I've seen a record for the end of the day. I don't need to wait for a 2-minute buffer anymore, and I can flush everything out. So let me paste this in. And then you can see it immediately outputs it because it says I read the data up to a certain point of time, right? So it flushes it out. So that allows you to kind of, flush out the records based on event time. So another thing to kind of mention, I talked about earlier that Flink handles out of order data well. So let's say, let me stop this job and clear this input queue. So I'm going to show you an example where I give it an out of order data. So you can see it's the same data, but all I've done is I've inverted some of the order. So you can see here 3 and 4, I've swapped it out. So 4 comes before 3, and then 6 comes before 5, and then 9 comes before 8, right? So you can see that I've kind of swapped it out of order. So what I'll do now is I'll just paste the data source here. And because I allowed lateness of 2 minutes, remember? So you'll wait for 2 minutes. But if I move one record to the very end, then, I mean, it won't show because it drops the record, right? Because I only allow 2 minutes worth of lateness. So let's say if I put it here, out of order, you get the same answer. So I guess, I'll just show you the one in order, kind of you can see. So 0, 2 in the UK, 2 in Malaysia, right? If you kind of go through it, you can see the same thing. And then if I flush the record as well, you kind of get the same answer as earlier, right? So you can kind of see Flink handles all of this out of order data for you because of the late handling semantics. So that's something that Flink can help you with. And I guess if your process in a real-time analytics pipeline, you want to ensure that you handle all of these situations because you won't think about it until it happens to you, right? And the thing about Flink is that it's been around for quite a while. It's 10 years anniversary now, right? So it's kind of a framework where we've kind of built and kind of ensured that there's semantics for you to handle real-time problems, right? Problems when coming to processing real-time data. So using Flink gives you and helps you to harness that power and experience that we have, right? So there'll be, I mean, Flink is quite a powerful framework, so there's a lot more that it can do than what I've shown. But I think just hopefully this gives you a taster and helps you to understand. And if you want to get started, I'm happy to kind of provide you some examples. And I guess if you're still interested in Flink, there are other talks that are happening that might interest you as well. If I can go here. So play from current slide. You can see like tomorrow, there's some talks by another Flink committer and PMC, Danny Kramer, who's going to talk about how does Flink actually work. So you talk about the use cases of Flink and also kind of the connector ecosystem. I mentioned Flink can read and write from multiple sources. That's what the connector is about. And there are a couple of kind of use cases that use Flink as well. You can see down here. You can kind of look at that on Friday. And then I guess there are some other AWS talks as well if you're interested. So 2 that are happening tomorrow. I've kind of put the location there. One is for Lambda and one is for microfinance discovery. Hopefully that's helpful. Cool. I have 2 more minutes. I'm happy to kind of field any questions if you guys have. Yeah.
Great talk. Thank you. When would I use Flink over Apache Spark?
Right. Good question. So so Flink like the difference between Spark and Flink is a kind of what is first-class citizen, right? So Spark is kind of by nature a batch processing framework. So it chops things into smaller batches and handles that, right? Whereas Flink handles each event individually. So one benefit of, I guess, Flink is that it kind of, the semantics that you get, you don't need to worry about like how you've chopped up the data. So how do I explain that? Let's say like you look at Spark streaming. What happens is that instead of processing each data individually, it just chops it up into mini batches and smaller batches. So the difference between batching and streaming data is that each event can trigger something, right? So you kind of, the semantics around like how you read, because I guess one thing to mention is that your events might not all come from the same key, right? You might key it by a different key, and then you want to process each event individually. So by processing each event individually, it allows you more powerful semantics during analysis. So that's the main difference between Spark and Flink. So Spark is by nature a batch system, so it chops them into small batch, but Flink is, by first-class citizen, is a streaming application, right? So everything that is built on per event triggers, right? So I guess the event time semantics and processing time semantics help you with that. Thanks. Oh, cool. Time's up. I'm happy to kind of answer your questions after if you want to kind of stay. Thank you.